Hi everyone, and welcome to this grade 9 mathematics lesson where we will be looking at identifying a function. My name is Miss Donnell Phillips. Let's get started. So what exactly is a function? Suppose we have two sets, set A and set B. A relation between A and B consists of connections linking the elements of set A with the elements of set B. A relation is called a function if each element in set A is connected with exactly one element in set B. We say that A maps to B, or that B is the image of set A. So we can use three different ways to identify a function. We could look at arrow diagrams, we could look at ordered pairs, and we could also look at graphs. So we could look at arrow diagrams, ordered pairs, and graphs, and we would be able to identify if it's a function or not. You can recall that in previous lessons, you would have explored the different types of arrow diagrams. We have a one-to-one type, a one-to-many, many-to-one, and many-to-many. Now, as long as the arrow diagram is a one-to-one or a many-to-one, then it is a function. So, if you have a set of arrow diagrams and you are asked to identify which ones are functions, then all you need to do is look for the ones that are one-to-one or many-to-one. Let's look at these two arrow diagrams. In the first, we have 2, 4, and 11 belonging to the domain, and 5 and 9 are in the range. If we look closely, we could see that 4 and 11 maps to 5, while 2 maps to 9. In this example, we have more than 1 going to 1. So this is not a function. However, if we look at the second one, we have 2 being mapped to 9, 4 mapped to 6, and 11 mapping to 5. And in this example, we have a one-to-one type of arrow diagram. So we could safely conclude that this is a function. Ordered pairs. An ordered pair is a point on an xy coordinate graph with an x and y value. For example, 2, -2. This is an ordered pair with 2 being the x value and -2 being the y value. When given a set of ordered pairs, ensure that no x value has more than one y value paired to it. If you look at an ordered pair and you can see that the x value is repeating itself, then it is not a function. By looking at an ordered pair, we could identify functions by ensuring that no x value has more than one y value paired to it. Example: which of the following set of ordered pairs are function? In the first set, we have 2, 1, 4, 5, 6, 7, and 8, 9. If we look at the x values, we have 2, 4, 6, and 8. None of them repeats themselves. That means that A is a function. B, we have 3, 6, 8, 5, 6, 7, and 22, 6. Let's look at the x values. We have 3, 8, 6, and 22. None of them repeats themselves. That means that B is also a function. C, we have -3, 4, 21, -5, -3, 0, and 8, 9. Focusing on the x values, we have -3, 21, -3, and 8. Here, we could see that 2 of the set of ordered pairs have -3 as their x value. Because the x value repeats itself, this is not a function. D, we have 2, 27, 3, 28, 4, 29, and 5, 30. Looking at the x values, none of them repeats themselves, so this is a function. E, 11, 14, 12, 14, 16, 7, and 11, 13. 11 repeats itself. We see that 11 belongs to the x value for 2 of the set of ordered pairs. Because 11 repeats itself, then it is not a function. And lastly, we have 3, 12, 4, 13, 6, 14, and 4, 1. X values are 3, 4, 6, and 4. The 4 repeats itself, so f is not a function. Graphs. Now, determining whether a relation is a function on a graph is relatively easy by using the vertical line test. If a vertical line crosses the relation on a graph only once in all locations, the relation is a function. However, if a vertical line crosses the relation more than once, the relation is not a function. Using the vertical line test, all lines except for vertical lines are functions. So here we have two graphs. In the first one, we have a circular graph, and we can see that 2 points from this circular graph falls directly under each other. So the first graph would not be a function. However, looking at the second graph, we could see that the vertical line only cuts the graph once, so this one would be considered as a function. So as we move this red vertical line across, in the first graph, we could see that it cuts the graph in 3 different places. For the second graph, it cuts it at 2 different places. So graph A and graph B are not functions. For graph C, as we slide it across, it doesn't cut it, it only cuts it at 1 point. That means that this is a function because it doesn't cut it more than 1 places. And for graph D, it's the same thing. It only cuts the graph at 1 point at a time. That means that this is also a function. So to summarize today's lesson, a relation is called a function if each element in set A is connected with exactly one element in set B. We can differentiate a relation from a function if we are given arrow diagrams, ordered pairs, and graphs. If the arrow diagram is either a one-to-one or a many-to-one, then it is a function. If the set of ordered pairs does not have the x value repeating itself, then it's a function. If the relation on a graph has more than 1 point falling directly under each other, then it is not a function. And to carry out the vertical line test, take a ruler or other straight edge and draw a line parallel to the y-axis for any chosen value of x. If the vertical line you drew intersects the graph more than once for any value of x, then the graph is not the graph of a function. I do hope that I was able to shed some light on how to identify a function. My name is Miss Donnell Phillips. See you next time.